Okay, for some reason or other the computer stopped responding, so I just had to restart everything again. And the program also now that didn't save this. The smartboard program didn't save number 4, so we have to do it from the beginning again. There's no problem. So that we see there's angles in a straight line. So y plus 50 equals 180y. So angles in a straight line. So 2y is equal to 130 degrees. So y is equal to 65. So that's 65 and 65. Then we say that x is equal to 65 because of corresponding angles. So that angle is equal to that then. So x is equal to 65 degrees, corresponding angles, with DC being parallel to AB. Okay? Are you going to calculate Z? It is alternate. Or you could have said interior angles of a triangle. Would have given you the same answer. So Z is equal to 65. Why? So alternate angles with AB being parallel to. You got all right. Well done to you. Okay. You all okay with that? So now we are on worksheet 10C is your homework. Okay. So now you got extra time now to spend on your maths. Not now, I'm saying like since you're dropping your physics and you're doing your consumers and she tell you to start with physics first. So you didn't listen to me. That is why you got what you got for maths. Makes sense? Start listening to me. Maybe it will change. Always start with your maths. Because then I imagine you pass physics but you fail maths. Then you can't do physics. But if you fail physics and pass maths, you can still do maths. And not do physics. Yes. Really good in physics. And you fail maths. Then you can't do maths. Then you fail maths, no? Then you must drop maths. Then automatically you must drop physics. Not you. That's why I always start with maths first. Alright, so book C is going to be homework for Monday, okay? Now we're going to go into congruency. It's going to refresh your memory. Okay, here we go. Listen. Just remind me on Monday when I'm trying to cut 3 or 10C that I've cut it already. Okay. So just a refresher when it comes to congruency. Congruency is your mathematical symbol for congruency is 3 lines across. Like equal, but an extra line. That means to say that 2 triangles are congruent if they have the same shape and size. They can fit exactly onto each other. Okay, that's also called rigid. It's like your rigid shapes. They fit exactly into each other, on top of each other. Okay. There are 4 cases for congruency. Okay. The first one being side, 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 where all 3 sides are equal. Then we have 2 sides an included angle. The angle must be between the 2 known sides. So if you got a triangle like this, and we know that side and that side, and we know that angle, that is not enough to conclude congruency. It must be the included angle. Okay? So when we use the side angle side theorem for congruency, it must be the included angle. Okay? As it's stated there, 2 sides and included angle. The third case for congruency is 2 angles and a corresponding side. So the side must be opposite the right angle. Like if you got these two angles equal, but you have that side known and this side was known, then that wouldn't be congruent. Okay, it must be the right corresponding side. Okay. So it must be opposite. How we know that? It needs to be opposite the correctly marked angle. Okay. The 4th case for congruency, you got the side at 90 degrees and an angle. Hypotenuse, a side at 90 degree angle. That's going to be your right hand hypotenuse side case for congruency. So there are 4 cases. Side, 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 angle, side, angle, angle, side, and RHS, which is your right hand hypotenuse side. Here's an example. The question says, prove that triangle ABC is congruent to triangle EDC. So we start off by always naming the triangle we're working with. So it's in triangle ABC and triangle EDC. What can we say? We're going to say that AC is equal to CE. Why? Given. Then BC is equal to CDY. Given. Angle C1 is equal to angle CY. T2Y. Vertically opposite. So what case of congruency is this? Side, angle, side. Can you see that? So we conclude therefore triangle ABC is congruent to triangle EDC. The order is important, people. Very, very important. Why? Because of the corresponding sides. Like here we got AB is equal to ED. AB is equal to ED. Can you see that? We can conclude that from the scene. We know that BC is equal to DC. We know that already. And we already know that AC is equal to CE. Also, angle A is equal to angle E. Angle A is equal to angle E now. You see that? Angle B is equal to angle D now. You see? And we knew that angle C is equal to angle C. That is why the order for congruency is very important. Okay, you guys got it? Most of the time, if they ask you, if not all the time, if they ask you to prove that that triangle is congruent to the other one, the order is already in its right order. Okay? Let's look at number 2. Example 2. You must prove that triangle ADB, this triangle, is congruent to triangle DAC. So what can we say? We can say that AD is a common side. Not so. Why? Because it's in both triangles. Alright, what else can we say? We can say that angle A is equal to angle D. I don't want you to say angle A, you must say angle BAD. It's going to be safer for you to say that. Okay, so write that in there. BAD is equal to CDA or ADC, the same thing. Is equal to 90. Why? It is given 90. Not so? Then angle D1 you see as a star here. D1 is equal to A1. Why? That was also given equally. So in other words, if we look at what we have here, we know that angle there, which was that one. We know that is 90, and we spoke about our side. So what case for congruency is this? Side or angle, side. You guys understand? So that is the congruency there. Alright, so we now on worksheet 10D. I'm going to give you a couple of minutes to do 10D. 10D is very similar to the one we just did in the example. So do for me 10D quickly. Number 1, followed by number 2. If you have a problem, you come to me now with it, okay? Followed by number 3. These ones are fairly simple. So while it's still as simple as it is here, capitalize on it. Make sure you understand everything. So later on when the diagram is a bit more complex, you know your basics is sorted at least. Okay? Then the more complex diagrams will become easier to deal with. Okay. At this point I'm going to pause the video. Okay, can I do the first two? Yes? Okay, so where do we start? We say in triangle ABC and triangle EDC. What can we say? Sorry? AC is equal to CEY is given. Next, BC is equal to CDY, also given. C1 is equal to C2Y, vertically opposite. So therefore, it's enough to conclude congruency. Triangle ABC, let's check, it's A, BC, so it has to be EDC. Yes, that is in the right order, it's congruent to triangle EDC. Why? So it's side, angle, side. This one, for this reason for congruency, it must be the included angle, not so in this case of congruency. And yes, it is the included angle, so yes, it is then correct. Let's go with number 2. Where do we start? We name the triangles we're working. It's in triangle ABC and triangle RPQ. It's ABC or PQ. Okay. What can we say? Sorry? AB is equal to PR. Why? It was given to us. What else? Sorry? Angle B. Yes? Equal to angle P. Are we just going to say P? No, it's going to be QPR. It's going to be better for you to say that. Okay, why? Given. So we either need a side or an angle. If we need the side, the only side we could use is BC and PQ, because there has to be an included angle. But they're going to work for us. Yes? You're saying BC is equal to PR. Huh? Are you saying B is equal to PQ? Why? Sorry? Common. When a side is common, it has to be in both triangles. Like that side is in that triangle and this triangle. Okay. So now it's not common. Or it is like this. You see this side here is in that triangle and in this big triangle. That's a common side. Doesn't mean to say it shares the same line with PQ that it's common, no. There has to be a side in both triangles. Yes? AC? Why? No, it's not given. It's given parallel. Yes? C2. Yes, we can work out C2. But can we work C2 out straight away? No. What can be worked out first? C1. C1 is equal to 90 degrees. Why is C1 90? It's alternate. Okay, you guys got it? C1 is 90. It's alternate angles with AC being parallel to QR. Then angle C2 is equal to 90. Why is that angle now 90? Angles on a straight line. Angles on a straight line adds up to 180. So therefore C1 is equal to C2 is equal to 90. You understand? So whatever I used the side, I used an angle and an angle. So which case of congruency is this? Angle, angle, side. So therefore, triangle ABC is congruent to triangle or PQ. Why? Angle, angle, side. Okay? Any confusion? No? Guys, finish number 3? Yes? Okay. So where do we start? We name the triangle we're working with. Not so? So I say in triangle ABC and triangle ADC. What can I say? AC is equal to AC. So AC is a common. AC is a common sign. Or you can say AC is equal to AC common. Whatever. Okay. What else can we say? BC is equal to Y. It was given on the diagram equal. So it's given. One more. Angle B is equal to, which is equal to 90. Why? Given. So this is enough to conclude congruency. Not so. So therefore triangle ABC is congruent to triangle ADC. And what case of congruency is this? We use 90 degrees. Have I used the side opposite the 90 degrees, which is the hypotenuse? Have I used the side opposite the 90 degrees? Yes. So, which is the hypotenuse. So what is your case of congruency here? Oh, that is right hand hypotenuse. 4 marks on the some ways. It's only if you want it, no? And none of us want it really. We want all the consumers. Right. Guys, finish number 4? Yeah. Who completed number 4? Only covering. Alright. So, the question is prove that angle A is equal to angle C. So in order to prove that angle A is equal to angle C, I need to prove what? That the two triangles are congruent, which means to say they will fit exactly on each other. Can you see that? So you guys go and prove congruency in these two triangles quickly. How many minutes left we have of this period? 2. And yeah, I thought we have another half an hour or so. Okay, it's fine. So I'm going to do this here before the bell rings, and then number 5 is part of your homework for Monday. Then you do for me. So for homework is going to be book C and book E. Book C and book E. Okay. That is for Monday. People, part of your homework for the weekend. No, that you should have started already. Oh, you're almost finished. Nice. You read through the properties of a quadrilateral. Familiarize yourselves with squares, rectangles, parallelograms, rhombus, kite, and trapezoids or trapeziums. Okay. Familiarize yourselves with these terminology there, and read through the midpoint theorem, what it says and all of those things. Okay. Because that's going to be next week's work. Okay. So let's do this quickly before the bell rings. So you see in this case, what do you notice? The triangles are not given to us. Can you see that? So we must give the triangles ourselves. So we say in triangle. So you see we start A, B, D. and triangle CBD. Okay? If we had got the order wrong here, it doesn't matter. But in conclusion, we must get it right. Okay? So what can we say? AB is equal to CB. Why? Given. Angle B1 is equal to angle B2. Why? Also given. Then BD is a common side. Not so. So therefore, triangle ABD is congruent to triangle. So if you've got A goes through the known line. So it's going to be C going through the known, which is B, and then to D. So yes, my order was right initially. And the reason here is going to be side, angled side. So in conclusion, we can say therefore, you see where A is, angle A is equal to angle. Therefore, angle A is equal to angle C. Why? Because triangle ABD is congruent to triangle CB. Okay? You all agree with that? Right. People enjoy the weekend and the rest of the day. Good morning, class.